So Josephine, if you look at the right-hand side here, where do you see a smaller example of sum?
Well, it's from n minus 1 onwards
Right,
towards the
so
right.
let me highlight what you say. So from here all the way to here
Yeah.
is a smaller example of sum. And in terms of, so n is the first thing that pops out if I say sum of n, right? If I say sum of dog, dog would be the first thing to pop out, right? Pardon me, so this right-hand side here, n minus 1 plus n minus 2 and so on, what would I put into sum to get this highlighted portion to spit out?
It would be sum of n minus 1.
Exactly. So I should be able just to replace this by sum of n minus 1. And this gives us a recursive formulation of sum. Now we have sum is equal to n plus the recursive call of sum of n minus 1. So this is almost exactly right, but what's missing is what? How do we get out of this?
We need to find a way to make it stop at 0.
Okay, so 0 is a fine place to stop. And so we would define, for example, sum of 0 equal to what?
0.
0. So we're able to take sum in its original open formula and write it as a recursive function by identifying and finding the substructure. So Casey, let's try this with the next one. So here we see multiplication. Now multiplication is something we could do much more easily than what's shown here, right? So this is a pedagogical example. But you see on the right that x is added together with itself y times.
Yep.
And if I do that, I'll get x times y, right? Where on the right-hand side here do you see a smaller example of multiplication that's just slightly smaller than the one shown here?